Warm greetings from the Department of Electronics and Communication Engineering, Rajeev Institute of Technology, Hassan, and the Institution of Electronics and Telecommunication Engineers, IETE, Mysuru Center. About IETE Mysuru Center. IETE started functioning in Mysuru since May 1994 as a sub-center. It was inaugurated by Professor B.S. Sonde of ISC, who had also served as the president of IETE. Dr. H.S. Shivram, the then professor and HOD of EMC at the National Institute of Engineering, was instrumental in starting the sub-center, and he was the founder chairman. Initially, the sub-center started functioning from the campus of NIE. The IETE Center Mysuru was shifted to its own building in February 2006, and it was upgraded as a center during August 2009. Subsequently, IETE Mysuru started conducting several continuing educational programs, hands-on workshop for students. The annual events like World Telecom Day, Foundation Day, Students Day, International Women's Day, and national conferences are being conducted by IETE Mysuru Center. Now, IETE is having its IT student forums at GSSS, ATME, MIT, NIEIT at Mysuru, MIT Thandavapura, Kaveri Institute of Technology Mandya, and Rajeev Institute of Technology Hassan. About Rajeev Institute of Technology Hassan. The college is located in Hassan. It was started as one of the galaxy in the technical colleges in the year 2008 under the aegis of Rajeev Education Trust. The college is built on a campus of about 21 acres. Rajeev Institute of Technology offers undergraduate engineering programs in 6 disciplines and postgraduate engineering programs in 3 disciplines. The Department of Electronics and Communication Engineering in RIT is emerging as one of the leading technical departments under the able guidance of Dr. Arvind N, Professor and Head of the department. In association with IETE Mysuru Center, the department is constantly conducting webinars, and the department students are actively participating in IT Student Forum, that is ISF. Today, a webinar on underwater wireless networks has been organized by IETE Mysuru Center in association with Rajeev Institute of Technology, Hassan. I would like to welcome the Honorable Chairman of IETE, Professor Nataraj CR, retired Professor, Department of Electronics and Communication Engineering, SJCE, Mysuru. I welcome you, sir, to this webinar. I would like to welcome the Honorable Secretary of IETE, Dr. Parameshachari BD, Professor and Head, Department of Telecommunication and Engineering, GSSS, Mysuru. Welcome you, sir.
Thank you.
I would like to welcome the Honorable Vice Chairperson of IETE, Dr. Bhagyashree SR, Dean Research, Professor, Department of Electronics and Communication Engineering, ATME CE, Mysuru. Welcome you, Madam. It's my pleasure to welcome the Honorable Treasurer of IETE, Professor Shashidhara S. Gokhale, retired Associate Professor, Department of Electronics and Communication Engineering, ATME CE, Mysuru. Welcome you, sir. It's my pleasure to welcome Dr. A.N. Ramakrishna, Principal, Rajeev Institute of Technology, Hassan, to this webinar. Welcome you, sir.
Yeah, thank you.
I would like to welcome the event coordinators, Dr. Arvind N, Professor and Head of the Department, Department of Electronics and Communication Engineering, Rajeev Institute of Technology, Hassan, and Mr. Rajesh KM, Assistant Professor, Department of Telecommunication and Engineering, GSSS, Mysuru. I would like to welcome the resource person of today's webinar, Dr. Yashwanth N, Assistant Professor, Department of Electronics and Communication Engineering, Rajeev Institute of Technology, Hassan. I welcome all the participants who have shown interest in this webinar. I welcome you all. Now, may I request Dr. Ramakrishna A.N., Principal, Rajeev Institute of Technology, to share his views about this webinar.
Thank you. Dr. Ramakrishna, Principal of Rajeev Institute of Technology. So it's my pleasure to join this webinar. The topic is the underwater wireless network. So it has been organized by IETE, the Mysuru Center, in association with the Rajeev Institute of Technology, Hassan. So it is really wonderful for me to join this webinar as it is one of the important topics. So because the speaker is Mr. Dr. Yashwanth, he is a faculty member of the Rajeev Institute of Technology in the Department of Electronics Communication. He has rightly chosen this topic to give something insight in respect of the application about the topic and also what are the challenges to be put forth for the upcoming. Is it not audible? I'm audible? Hello?
Yes, sir, you are audible, sir.
Yeah, okay. Sorry. So at the outset, I would like to thank the organizing committee of IETE and also the speaker, Yashwanth. So given the opportunity to our institute to participate under this IETE. So the topic I already told, underwater wireless network is having many applications, like it's to deal with predict surveillance, sea pollution discover, and also sunken ship identification, etc. The many challenges are there. So when we deal with underwater communications, so we challenge localization effect due to aquatic problem, and also in respect of the routing protocols. So therefore, I hope the speaker will going to be give insight about all those topics or some of the important area wherein the participants will get the benefit and also they will go ahead with the aim to research activities to complete their further invention. So I really thank the organizing committee of IETE and also the speaker for giving me an opportunity to speak few words on this occasion. Once again, I wish you all the best, each one, to organize this webinar in association with IETE as well as our institute. Thank you, one and all. Thank you.
Thank you, sir.
Madam, over to you.
May I now request Dr. Arvind B.N. to introduce the speaker of today's webinar, Dr. Yashwanth N, to the session.
Thank you, madam. It is my privilege to introduce today's resource person, Dr. Yashwanth N. Dr. Yashwanth N completed his in the field of signal processing and VLSI from Jain University. He completed his PhD from Visvesvaraya Technological University, and the title of his work is Localization in Underwater Wireless Sensor Networks. His research was knowledge of engineering and he completed his research with Dr. B.R. Sujata Madam, Professor and HOD, Department of Electronics and Communication Engineering, Malnad College of Engineering, Hassan. Here he is having around 6 international journal publications, and he has delivered his words in around 5 international conferences. He also submitted proposals to Naval Research Board, DRDO, and VTU. He presented invited talks at Department of Studies in Electronics, PG Center, Hemgangotri, Hassan, as a part of lecture series funded by the University of. He is also reviewer for international journals. He has attended more than 22 sponsored short-term programs or the FDPs and other certification programs. He also visited the Malaysia for the purpose of presenting a paper in the conference. So I wholeheartedly welcome Dr. Welcome you, sir. Over to Ambika, madam.
Thank you, sir. Now, the session will be handed over to Yashwanth.
Okay. Good morning, participants. Thank you, Dr. Arvind BN, for introducing me to the participants. I also thank Mrs. Ambika K for handling this Master of Ceremony. And I wholeheartedly thank Dr. N. Ramakrishna for giving me this opportunity to share my knowledge with the participants. So before starting my session, so I'll be thanking IETE Mysuru Center and our college, Rajeev Institute of Technology, Hassan, for giving me this opportunity to share my knowledge. And I request the participants to spare their 30 to 40 minutes of their time so that some participants may get like excited with the topic and continue doing research in underwater sensor networks. So I'll be sharing my slide. Okay, so my topic is underwater wireless networks. Uh, I will walk you through the overview of my presentation. So I'll be starting with the basic introduction of what is underwater wireless networks. So I'll be explaining the UWSN architecture. UWSN is underwater wireless sensor networks. The different modes of communication in underwater environment, the communication characteristics, the different applications which can be considered while using this underwater communication, the acoustic communication characteristics, the research issues and challenges. Basically, I say it as research gaps, and localization, which was my research area for some 4 to 5 years. The simulation softwares which are present where we can do the simulations in underwater environment. So here I'll be starting with saying like we know that Earth is a planet which is covered by 2/3 of water. So more than like huge resources are yet to be discovered when we consider water environment. Let me start with a joke. Like if we had this underwater wireless sensor networks, previously we could have found out the different treasures which are present in the water environment. The Titanic ship could have also been like uh, found out very easily. So since I'll be explaining it, you will be getting to know how we can explore things in the water environment by using this underwater wireless networks. So for discovering this, the possible idea is having underwater sensor network. So this underwater wireless sensor network is a network of autonomous sensor nodes which are distributed in an underwater environment. So it can be river, it can be sea, or it can be ocean, anything like that. So since there is a growing interest in this underwater exploration, so many research activities are being taken for this topic. Okay, so before moving to the next slide, like I want to say the overall generic topic of underwater wireless networks. The generic topic is underwater wireless sensor networks. So here in my figure, you can see. So this is a water environment. Consider this as a sea. So we have this surface sinks. So surface sinks are basically above the water environment, and all the sensor nodes which are present will give the information to the surface sinks. So all these nodes which give the information in the surface sink or to the surface sink give the information in acoustic form. Acoustic is sound by using sound signals. So since many signals like RF, radio frequency, electromagnetic waves do well or doesn't perform well in water environment, we go with acoustic signals. I'll be explaining acoustic signals briefly in my next slide. So if the bottom node need to convey the information to the top node or to the surfacing, what it will do is the bottom node will give the information to the intermediate node in a multi-hop fashion. So this is how the information is transmitted by hopping. Multi-hopping is jumping, okay, multiple jumping and finally giving the information to the concerned processing unit. We have different modes of communication in water environment. The researchers use these modes of communication. So here, as we can see from the figure, the acoustic waves travel more in water environment. The microwave doesn't perform well compared to the acoustic signal, and the blue LED will perform, but not up to the extent of acoustic. And finally, blue laser will perform well compared to the other two. And we can have an option. The more research is going on in this area. Okay, blue laser technology area. We have many disadvantages also whenever we are considering a technology. We have many advantages and disadvantages. So acoustic wave communication has also many disadvantages and advantages. The main advantage is it doesn't lose the data. It doesn't lose the data, and it travels for longer distances compared to the other technologies. So we will see the different advantages and disadvantages of most popularly used communication techniques in underwater wireless sensor networks. These communication techniques also can be applied to wireless sensor networks, but there is a trade-off. When we consider underwater environment, there are many challenges. That's why we need to configure that technology properly so that it can fit to the underwater communication. Fine. So these are the different like popularly used technologies in underwater communication modes. So the first one is radio frequency. So we know radio frequency. Radio frequency is very extensively used in terrestrial environment, that is above water. So it is widely accessed and speed is very high, 2.25 into 10 to the power 8 meter per second, very high speed. But we have limitations when we consider it in water environment. It attenuates more. It has limited electromagnetic spectrum, and it travels for up to for very short distance, that is only up to 10 meters. When we consider acoustic, the signal travels for a longer range, and it is basically currently most popularly used communication media when we consider underwater environment. But it has limitations, as I said. The propagation speed is very slow, that is 1,500 meters per second. This is 10 to the power 8. So this is only having 1,500 meters per second. It has high propagation loss. It has multipath effects, since there will be many impurities in the water, there may be chances of reflections happening, and we may not get the data properly, and it has high delay. Okay, the delay is more since the speed is very less. Okay, so one of the like booming research activity, like research technology, is optical communication. So many research as is being going on in optical communication. It has high data rate. It doesn't have licensing issues. The speed is very high, same as radio frequency, but the distance. So distance matters, because whenever we are placing a sensor, so before going further, I need to explain sensor. So sensor doesn't mean a small device. Sensor consists of many components within itself. Sensor consists of a microcontroller. It consists of a transceiver to collect or send the data. It consists of a battery device, so that it should have longer lifetime. Since we are placed inside water, we cannot remove it frequently. It has a processing unit, and so on. So a sensor module is a bigger thing, and also it should be waterproof. Very, very important, since we are embedding or putting into water environment. So as of now, the researchers mainly use acoustic signals for underwater communication. So we have communication characteristics when we consider acoustic and radio frequency. So radio frequency, uh, since it doesn't travel longer distances and it attenuates quickly in water, we basically use acoustic communication. So if we are using radio frequency, it should have large antenna, it should have high power, so energy consumption will be more. Since we are talking about energy consumption, since see, we put the sensor nodes in water, we cannot take it out frequently, we cannot put the battery inside frequently. That is why we look into energy efficient sensors. So the energy consumption should be very low. That is why we use multi-hop techniques. We make a cluster head. We have a smaller area, so cost effectiveness is also more. So that is why the uh, RF technology cannot be used uh, like practically in water environment. So we have different applications in underwater. This one, underwater wireless sensor networks. So basically, the main application can be environment monitoring. So the climate change, we can predict the climate change. Like we can detect the tsunami, because sensor nodes may get placed in the ocean bed. So due to the drifting of the soil, we can predict that there may be chances of tsunami. We can have pollution control, since the oil and gas fields will extract oils from the water environment. So we can use it like pollution. If the pollution is more, we can control it. We can predict the natural disasters. As I said, tsunami can be controlled. The harbor protection, since harbor in the sense, consider an enemy submarine is entering into our country. So by placing the sensor nodes at the borders of our country, we can have we can say that some enemy is entering, so that we can take necessary action. It is used for underwater explorations, so discovery of natural resources, the marine phenomenon, deep sea archaeology. Archaeology helps in many ways, so that we can have a path in the water environment. So path in the sense, we can have a map of the water environment, and we can easily have a route map. Like, since we have roads here, right, in terrestrial environment, in above water, likewise we can have a map, and we can travel easily, so that there will be no like obstructions or something like that. It is also used for scientific data collection. So oceanography is one of the like booming branch in IITs and NITs. Oceanography is a branch there. Okay, we can go with geosciences, we can go with marine biology, survey, military and non-military operation, detection of objects. Yeah, Titanic, I just said. So detection of objects, it can be used. So ocean bottom imaging and mapping. So imaging will give us a map, so that we can travel easily. So that is what it helps. So for all this to happen, as of now, acoustic communication is very, very important. So because the sensors need to communicate, the sensors means all the five components. The sensor doesn't mean a small thing. Okay, so the sensor need to have proper communication. It doesn't, it should not lose any packets in the sense data packets. It should not like uh, it should not synchronize, it should synchronize properly and so on. Okay, so we go with acoustic communication. So in shallow water environment, we can place the acoustic like sensors in the uh, top part of the ocean, but in deep water environment, the placing is very difficult. So we take the use of anchor nodes. Anchor is keeping it in a particular in a small place, like in the place where we need it. Okay, anchoring. So all the ships will have an anchor like structure, so that the ship stays in that place. So we take the use of anchor nodes, we take the use of other sensor nodes. So depending on uh, all the characteristics, since research has been done in many different areas in with respect to underwater wireless sensor networks, acoustic communication is considered as the best communication for long distance, like long distance communication. Okay, long distances. So to have a communication like acoustic communication, the channel should be properly controlled. So what is the channel? Channel is the bridge between transmitter and receiver. So the channel what we are using should be properly modeled. So channel modeling is a important research area when we consider any wireless communication. It can be just wireless sensor networks, it can be underwater wireless sensor networks, any communication, any sort of communication. The channel modeling is very, very important. So channel, we have many like channel characteristics. So the channel modeling need to be done to control the speed of sound, because speed of sound is only 1500 meters per second. So we need to effectively make it 1500 meters per second. It can be reduced, but we need to make it 1500. It can attenuate, the signal can attenuate, we need to control that. It can have multipath effects, we need to avoid that. Since yeah, noise is everywhere, so noise happens because of many factors. So noise should be controlled. So by having all this into consideration, we can increase the signal to noise ratio and you can have a optimal transmission frequency. Okay, so all these characteristics are required to have a proper communication, to have a proper channel modeling, because channel plays a major role when we are considering communication. There are different research issues when we consider underwater acoustic communication. So research issues such as like bandwidth efficiency, power consumption. So bandwidth should be high, the power consumption should be low, and we need to have a statistical knowledge about the channel fading, which could be useful parameter in designing of adaptive systems. See, adaptive signal processing is important there. Like it should, the sensors should learn and adapt to the water environment, the adaptive, and also the coding techniques. Because when we are talking about uh, communication, we need to have modulation. So modulation is very, very important. So modulation should be done, coding techniques need to be used so that the intruder should cannot take over data. So efficient space-time coding techniques need to be exploited for considering time, proper frequency, and spatial diversity in underwater acoustic channels. So by looking at all these research issues, having a basic knowledge of underwater wireless sensor network, by knowing what is a sensor, by knowing what are the applications of sensors, we can say there are different challenges. There are like lot of challenges when we consider underwater communication. Uh, the challenges can be named like this. So it is a short range acoustic communication. Okay. So the short range, because water environment, hundreds of meters is also not enough, because the sensors cost is very high. The sensors will move from one point to another because of the movement of like drifting of water, because of the movement of whales or underwater aquatic animals, because of the movement of submarines. So sensor nodes will move here and there. So whether we put a lot of money or not, the sensors will not ask our opinion, because in terrestrial environment, what happens is terrestrial is above water. So terrestrial environment, the sensors are placed in a fixed place. Okay, we know the coordinates of it. We know the actual location of it. But in water, deployed, since they are deployed, they are moving here and there because of the things which I said, like because of drifting water currents, submarine movement, aquatic animals movement, and so on. So this is one of the challenge. So we need to have medium access control properly into consideration. We need to have a time synchronization between the sensor nodes, because in a water environment, many sensors will be placed, and all the sensors need to be like communicating with each other in a synchronized fashion. Okay, synchronization should be properly done. The localization protocol should be followed. So I'll be talking more about localization in the further slides. To avoid this latency effects. Okay, latency is delay. Okay, so application level data scheduling should be done. So now researchers are currently exploring so how to extend the benefits of terrestrial environment. We have many algorithms which are taken into account when we are considering terrestrial environment. So now we need to import, like export, we can say export that into underwater sensor networks by having modifications, because those and these doesn't work. We need to have the base technology, and we need to configure it, and we need to apply it to underwater sensor networks. Another challenge is building a scalable network. Okay, scalable is having any number of, like, more number of sensors for having some particular applications in the water environment. And whenever we add those sensors, all the sensor networks will synchronize, will need to synchronize with itself with all the sensors. Okay, so this some of the research challenges can also be like we initially deploy the sensor nodes and it will disperse anywhere. It can go anywhere. So that is why we need to take care of that. So to have any applications, so I told about some 10 to 15 applications. To have any applications into our account, we need to have a term called as, we need to take into account this word, that is localization. Okay, localization is getting the exact location of the sensor node, getting the exact location in the water environment. That is the major challenge we are facing. So see, localization is very much important. So without localizing, we cannot have any of the applications. We need to localize, that is have the coordinates of the sensor node first, collect the data and send it to the seashore processing unit. We need to localize the sensor nodes. We need to have the location of different things. So that is why localization is one of the important topic in underwater wireless sensor networks. Okay. So as I said, see, knowing the own position of the sensor nodes and also the neighboring position, so that is what is called as localization. So that is accurately we need to determine the position of the sensor node. So that is why we have different methods to do that, but with many challenges since it is a water environment. We have trilateration method, we have time of arrival technique, we have time difference of arrival technique, multilateration method, and we have optimization algorithms to do those. So we have many methods to localize the sensor node. So I'll be telling some important methods which is most popularly used, that is time of arrival and time difference of arrival techniques when we are considering this localization of sensor nodes. Okay, so why localization? So without localization, we cannot do any of the applications. First, we need to locate that person or that sensor, and we can implement anything on them or in that sensor. So the most popularly used localization techniques is TOA and TDOA. That is time of arrival and time difference of arrival technique. So see, TOA is very simple. This one simple technique. So it works on this GPS technology, global positioning system technology. So what happens here is, consider this as the target node. Target node here is nothing but target sensor node. Okay, target sensor node is nothing but the node which need to be localized, which whose position is to be known. So that is why it is called as target node. So these are beacon nodes. So beacon nodes are nothing but I previously said anchor nodes. So we already know the position of these three nodes. We have already placed this. Okay, we have already placed the sensor nodes in that particular. We have anchored it. Okay, we have put it in like in a fixed place. So by having the time of sending the packet and time of receiving the packet, we can have a small circle for a particular beacon node. And by this, for this beacon node 1 also, the same thing, sending time, receiving time, we can draw a circle into it. And similarly for beacon node 3, the same thing happens, and we can find the position of the target. That target here is the sensor node which need to be localized. So this is one of the important technique, that is TOA. It is also known as trilateration technique. So this technique is also used in your GPS. So whenever we put our maps, Google Maps or Apple Maps, so what it will do, it will take the help of the three different satellites which are like placed above us, and it will give the exact location of the target. That is the mobile which you are carrying. So similarly, we have one more technique known as the time difference of arrival. So here in this, what happens? It will take the difference of sending, only the sending time, not the receiving time. So it creates a hyperbola like structure, and it can find out the target which is placed, that is which need to be localized. So we have I was talking about the different sensor nodes. Okay, so there are basically three types of sensor nodes. The one is the anchor node, and second one is reference nodes and non-localized nodes. So our aim is to localize this non-localized nodes. So that is our main aim. So anchor nodes are basically high energy nodes. So it is the, what we can say, it is the highest head, like it is the head of any institution, we can say that. Okay, so anchor nodes has more energy, so it helps in localizing other sensor nodes. We already know the location, we can say that we already know the 3D location of it, and we can find out the location of the non-localized node. So reference node is a tricky one. So reference node is or was previously a non-localized node, but beyond a preset threshold value, which we have set in a software or any hardware, it will convert itself into reference node and helps us to localize the other non-localized node faster, in a faster way. So that is the role of reference node. So three nodes, basically two nodes, anchor and non-localized node. The non-localized nodes will be converted into reference nodes. So by considering this UWSNs, by considering this localization, by considering the different sensors, we can have many experimentations. We have done some experimentation, though we can see here this localization technique can be applied to shallow water environment. Shallow is upper part of the sea body, okay, and deep water environment. So we can say that shallow gives better results, deep doesn't give better results. So we need to configure itself. We can have the localization of nodes with and without reference nodes. Previously, I said three nodes are there. So with and without reference node, we can do that. But with reference node, it will give good results. And we can go with the different deployment strategies. Basically, what happens is we follow the random deployment scheme. That is, having a water environment, just deploying the sensor nodes. Anchor will be there, just deploying the non-localized nodes. So we can go with different deployment strategies, like we have cube deployment strategy, we have regular tetrahedral deployment strategy. We have different shapes of deployment strategies. So basically, the best deployment strategy is regular tetrahedral deployment strategy, which we can find it on in our different research papers, and we can have experimentations done on bio-inspired algorithms. We have particle swarm optimization algorithm. These are the students just need to know bio-inspired algorithms. But if the faculty, if a faculty is seeing, so we can have particle swarm optimization algorithm. We can have butterfly optimization algorithm. We can have other salve swarm optimization algorithms and so on. So many experimentations can be done when we consider an underwater wireless sensor network. So we have many research areas, research gaps we can say, by considering this water environment. Why I say water and water? Because we have many research gaps. So everyone in this uh, participants list can have a different research problem and do research on it. Okay, so that is why it is a very very good when we consider this. Okay, we have different open problems of research here. So I'll be naming a few. We can do statistical channel modeling. Channel modeling is modeling by considering the noise, by considering a good SNR, by considering multipath effects, and so on. So we can increase the network capacity. We can have the data compression because see, while sending, the sensors uses less power. It should use less power. So we'll compress the data and send it. Okay. So and the decompression will be done in the sync node. Sync is upper part of the node. We can do node localization. Why I stressed on node localization is because I did research for 3 to 4 years on node localization. We can do signal processing for communications in water environment. We can go with adaptive modeling or coding techniques. We can go with channel estimation or prediction. So multiple in and multiple out channels, that is transmitting and receiving arrays, we can consider. So we can go with multi-user communications. So a single sensor transmitting or broadcasting itself to many different sensors. Communication in a hostile environment. We can also go with communication networks. So network layout, resource allocation, and resource reuse can be taken into account. The network architecture can be controlled. The network protocols, that is different layers, 7 layers we have. So network protocols can be controlled. We can do simulation experiments. We can do hardware experiments, that is going into water and doing, and we can have a prototype of the experimentations as the research what we have done. So to do all this, we have different simulation softwares because see, real-time exploration or having a hardware designed for it is very costly because according to my knowledge, a single sensor node, what I am talking, costs around 37 lakhs in India because it is imported from some other country. Designing a sensor node is also a good research. Now, okay, so before doing any hardware thing, we can go with software simulations. We have many softwares to do that. So we have Aqua-Sim. Okay, Aqua-Sim is Aqua Simulator. It is a NS2 based software, network simulated 2 based software. So it helps us to have 2D localization, X and Y coordinates. We have Aqua 3D. It is an NS3 based uh, uh, module where we can get the 3D localization of the sensor nodes. We have OpNet, we have Sunset, we have UnitStack. UnitStack is a new technology, it is under networking stack. Okay, UV is under network. So it is developed in Singapore by Acoustic Research Laboratory by Mandar Chitre. So he is the helping hand behind this UnitStack. So this is one of the emerging software now. So this Aqua 3D gives better results, that is 3D results. And if we want 2D results, to start with, we can go with 2D values. We have for doing those, we have many softwares, OpNet, Sunset, UnitStack, NS3, NS2, and so on. Okay, so since I set some fundamentals on underwater wireless sensor network, so you have got a basic idea of how underwater wireless sensor networks work. So sensor networks placed inside water, communicating with each other, giving the information to the shore environment is underwater wireless sensor network. So for this, I have referred many papers. So many more. I have around 20 to 30 reference papers. So just I mentioned some 6 reference papers. Anyhow, so this was my topic, which I tried to share with you, that is share with the participants. So I'm very thankful for my college and IET Mysuru Center for giving me this opportunity to share a few knowledge, like share some knowledge with you people. If you have any doubts regarding this topic, you can have my email ID here. You can contact me anytime. Students, faculties, research scholars. So anyone can contact me regarding the software requirements, regarding the different different experimental scenarios. You can contact me, and I'll get back to you. Uh, yeah. Thank you. Thank you.
Thank you, Yashwanth, for presenting the webinar on underwater wireless networks conducted by IETE in
I
association with.
forgot, madam. One second. I forgot one thing. Like, if you have any questions, you can ask me. I went to the last slide. You can ask any questions related to underwater wireless sensor networks. I'll also share my this one. Yeah. If you have any questions, you can ask me. Any participant, or you can email me directly so that I can clear your doubts. Do you have any questions? Anyone from the participant? Okay, madam. I think they don't have.
The webinar on underwater wireless networks, it was conducted by IETE in association with Rajeev Institute of Technology, Hassan. Our heartfelt thanks to the Honorable Chairman of IETE, Nataraj Sia, BD, the Honorable Vice Chairperson of IETE, Dr. Bhagyashree SR, Honorable Treasurer of IETE, Professor Shashidhara S. Gokhale, and our sincere thanks to Dr. A. Ramakrishna, Principal, Rajeev Institute of Technology, Hassan. And also we are grateful to the event coordinators, Dr. Arvind B.N. and Mr. Rajesh K.M. Our thanks to Dr. Yashwanth for presenting the seminar. I thank all the participants who have shown interest in being a part of this webinar on underwater wireless networks. Our heartfelt thanks to all the participants for playing a role in the conduction and completion of the webinar. Thank you, one and all.